Hit record. All right, let's get rolling. So first thing, let's kind of look at what we did yesterday. So first thing, let's look at this warm up. So what's the difference in the holes, the vertical asymptotes, and these zeros? So first of all, if we're looking at all of these, we got a hole, we got a vertical asymptote, and we got a zero. So if we remember holes are solutions to the factors that are canceled. So if anything gets crossed out, that becomes your hole. So the solution to that, we're saying equal to zero and solving. Vertical asymptotes are solutions to the denominator. And this is always after simplifying. That is not how you spell simplifying. That is how you spell simplifying. And then the zeros are the solutions to the numerator or the top. Everything today hopefully will tie in for you, make it a little bit better. It's kind of how we're going to start on the front, and then on the back we're going to get to graphing. So kind of a real quick refresher. Looking at this one, we're going to find find the holes, the vertical asymptotes, the horizontal asymptotes, the zeros, and get back to where we were, just to double check, make sure we got everything. So here, let's factor what I can. No, sorry, Casares. So what factors of 8 subtract to give me 2? It's x minus 4 and x plus 2. Now here, this one's a little bit different. What factors of negative 8 give me negative 7? So negative 8 and 1. But remember, I have to divide that by 2. So I get an x minus 4 and a 2x plus 1. So make sure the very first thing, if you didn't get this sheet yesterday, print it at home, get it. It's on yesterday's notes, today's notes, and tomorrow's notes. This one, the big one. This one, guys, the big one. You didn't get this, please keep that with you. Use this every time you're graphing rationals. All I'm going to do is follow through the steps and kind of look at different things. So here, I always want to factor everything. First of all, does anything cancel? Yes. So that cancels. So I'm going to go ahead and write holes. I got x is equal to 4, right? So those cancel. So I have a hole at x is equal to 4. Vertical asymptotes, I'm going to set the denominator. So I'm left here with x plus 2 over 2x plus 1. So the vertical asymptote, you set the denominator equal to 0 and solve. So 2x plus 1 is equal to 0. So x is going to equal negative 1/2. To find our zeros or our x-intercepts, we set the numerator equal to 0, so x equals negative 2. I know I can do that kind of quick. And then my horizontal asymptote's the weird one. All I'm really looking at, well, I guess that's the simplified form, but is this part right here, because that's a degree 1 and a degree 1. So my leading coefficients are 1 and 2. So y is going to equal 1 over 2, because they're the same degrees up top and up bottom. This is a little clearer right here as well. They're both a degree 2, so they're the same. So I always look at the leading coefficients. So I got a 1 here and a 2 here. So my horizontal asymptote is going to be at 1/2. Does anybody have any questions about any of that before I move on? That was yesterday in a nutshell. Just a lot faster. I went super slow yesterday, and the video was like 8 or 30 minutes or something like that. It's all good. All right, domain. Last thing I want to talk about before we get to a graph. So to find the domain, we're going to look at the x values that we could substitute into the equation and still get an answer. That's the definition of a domain, every x that has a y. So for rational functions, the domain will always be all real numbers except for your vertical asymptotes and your holes. So we're going to find our vertical asymptotes and our holes, and it's going to be all real numbers except for those. All right. So if we're looking at these graphs one by one, so nothing can cancel here. You can tell by the picture, I have a vertical asymptote at x is equal to 5. There are no holes because nothing cancels out. There's no open circles on the graph either. You can also tell the vertical asymptote by the denominator. Same kind of concept. So your domain here is going to be all real numbers. So remember that symbol, it's like a big R with 2 things. So that just means all real numbers. So all real numbers except x is equal to 5. That's one way to write it. I'll show you another way to write it on the second one. So all real numbers except for x cannot equal 5. Because at x is equal to 5, that is a vertical asymptote, so it does not equal anything on that line. All right, let's look at the next one. So over here, does anything cancel?
No.
No. So we're good to go here. X is equal to 3 is my vertical asymptote. So 1, 2, 3. I can get you a sketch here so you can see it. No holes. So I have a vertical asymptote at x is equal to 3. No holes. So here, my domain, another way to write it is going to be all real numbers except for x cannot equal 3. So you can write it like that, or you can actually write except x can equal 5. Either one's fine. I don't really care. They both mean the same thing. I'm going to go from there. All right. So looking at these without a graph, kind of going a little bit quicker through these. So here, those cancel. So I have a hole at x is equal to -1. I got a vertical asymptote at x is equal to 3. I know I'm going kind of quick. If I go too quick, let me know. So the holes, that cancels. So that's my whole vertical asymptote is the denominator. If you want to rewrite it, that's what I'm actually going to be dealing with, 1 over x minus 3. So my domain here is going to be all real numbers except for x. I don't like that way. I'm just going to write except for x cannot equal -1 or 3. So there is my domain. So all we're looking here, we're just looking at the holes in the vertical asymptote piece. That's all we are concerned with. All right, number 2, let's factor. So I got x squared over, that's a difference of squares, so x plus 3 and x minus 3. Please do not cancel out the x squares, y'all. Don't do that. It's just bad. You have to have a whole factor to cancel out. So I have no holes. Vertical asymptotes at x equals 3 and negative 3. So that means my domain is going to be all real numbers except for x cannot equal 3 or negative 3. We're good to go. All right, I'll leave that one up. Try number 3 really quick. See what we get. So factor it, find your holes, find your vertical asymptote. And let's go from there. I'm gonna come back to that. Just give me a second. I don't think I put it up, so never mind. Let's see. So holes here, I got x is equal to 3. Vertical asymptote here, x is equal to negative 7. And you see, when you're looking at it, the whole denominator is taken care of, right? Both of those factors are taken care of. So my domain is going to be all real numbers except for x cannot equal 3 or negative 7. And we're good to go. All right. Any questions on that? I'm going to start throwing it all together. I think I got 3 or 4. Yep. So I'll put this up in a second. So you can see it. I'll put this up at the end of the class so you can copy it down if you didn't print it. But here's a checklist that's easy to follow. So we're going to factor what we can. X-intercepts, those are your zeros. So we're going to set the numerator equal to 0 and solve. Step 3, find the y-intercepts. That's going to help you out. That's just giving you another point to graph. So it's where does it cross the y-axis? And that's just setting x to 0. So you're going to plug 0 in for x and get an answer. Find the vertical asymptote. So you set the denominator equal to 0 and solve. Find the horizontal asymptote. Remember, this is your 3 cases. So case 1, they're the same. So you look at your leading coefficients. Case 2, it's top heavy. So if it's top heavy, there is none. And then case 3, it's bottom heavy. And it's always y is equal to 0. So it's all going to be in one spot. We're not going to do number 6, but this is a slant asymptote. We might get there eventually, but I don't think we're going to have enough time. Then plot everything that you know on a coordinate plane and use some test points and then find the limits. So that's going to be a little bit upper level. I always put a star here. Don't forget your holes, please. Put that up by factor. So if you cancel anything out, please don't forget your holes. So that right there, it's up on E-class. You can add what you need to it as well. But that's the easiest way to graph. So let's look at a couple of these. I gave you a couple of other directions up there, but I like this. So let's find all of our information. First of all, let's see if anything can factor. So this factors into x plus 4 times x minus 4. So this cancels. So I have 1 over x minus 4. So I'm going to go ahead and find all of my information that I know. So first of all, holes. I have a hole at x equals negative 4, right? Vertical asymptote. Set the denominator so x is equal to 4. Horizontal asymptote, it's bottom heavy, so y equals 0. Zeros, I don't have any because the numerator now is 1. I like to find my y-intercept just because that gives me another point on the graph. So if I plug in 0 for x, I got 1 over 0 minus 4. So I got negative 1/4. That just gives me another point to graph. All right, so what I have here, so you can see it, I got a vertical asymptote here at x is equal to 4. I have horizontal asymptote at y is equal to 0. Okay? I know on my graph 0, negative 1/4 is going to be there, so that's here. That's all I know right now. Does that make sense? I know I have a hole at x equals negative 4 somewhere, so over here there's going to be a hole. So I can go ahead and put that. So lastly, all I want to do is kind of get a chart, something a little bit close to, depends on how many points you want to do. 1 or 2 is fine. I at least like to do 1 to the left and 1 to the right of your vertical asymptote. So 4 was my vertical asymptote, so that's why I chose 3 and 5. So if I take 3 and plug it in, I got 1 over 3 minus 4, so 1 over negative 1 is negative 1. If I plug in 5, I got 1 over 5 minus 4, which is just 1 over 1, which is 1. So that gives me at 3, negative 1 I know is on the graph. No, 5, 1 is on the graph. So it's an extra point to graph. And then rational functions, that tells you where we're going. So what they do is this. They kind of curl. And go from there. So plugging in the 3 and plugging in the 5 is going to tell you which quadrant you're in. That's a good enough sketch for me here. So state the domain. So in your domain, it's going to be all real numbers except for x cannot equal your hole, which is negative 4, and your vertical asymptote, which is 4. So all of that information is what I'm looking for. Okay. So all this information from yesterday, and now we're just going to take it and we're going to apply it to getting a sketch. You can always type it into a graph on a calculator and look at it, or you can use your Desmos and going from there as well. All right, let's go over to number 2. What's up? Okay, so the table, what I'm doing for the table here is I'm taking my asymptote right here, and I'm picking 1 to the left, which is 3, and 1 to the right, which is 5. So the asymptote divides it. The asymptote's there, divide it into 4 pieces. Okay, so the asymptote, we can't have anything on top of each other because that makes it not a function, because then it fails the vertical line test. So if I pick the number 3, it's either going to be in the bottom left or the top left. So if it's in the bottom left, I know I'm going to have that little curve down in the bottom left. And I got 3, 1 when I plugged it in. I plugged it in the simplified equation right here. So I got 1 over 3 minus 4, and you get negative 1. And then the same thing, I pick 1 on 5. It's going to tell me if it's in the top on the bottom. Usually, if it's in the bottom left, it's going to be in the top right. Or if it's in the top left, it's going to be in the bottom right. So I'm going to have those two. I don't want to say all the time because it's not all the time. Sometimes they're both up top or they're both on the bottom, depending on the top function. So that's where we're at. All right, let's look at number 2. So let's look at this. So finding all of my information here, nothing can be factored. So holes, I don't have any. I just like to write it out of habit. Vertical asymptote, x is equal to negative 3 because that's the denominator. No zeros as well. Horizontal asymptote, it's bottom heavy, right? So y equals 0. And then I have to add that 2 from the end. So y is going to equal 2. We talked about that yesterday. Still with me? So let's go ahead and see where we're at. So vertical asymptote here at -3. Horizontal asymptote here at 2. I'll keep it basic for you guys. So x and y. So my vertical asymptote over here was at -3. So I'm going to pick -4 and I'm going to pick -2. Because right here at -3, that's my vertical asymptote. So if I plug in -4, I got 1 over -4 plus 3 and then plus 2. So that's going to be what? -1 plus 2, which is 1. So I got -4, 1 is on my graph. So -4, 1, boom. -2, so 1 over -2 plus 3 and then plus 2. So I got 1 plus 2, which is 3. So -2, 3 is going to be in my graph. So that's here. So that's enough information for me to get a sketch. So all I'm looking for is just a sketch. So I know I'm going to come here. I'm just going to go there and there. Boom, boom. Then lastly, my domain is going to be all real numbers except for x cannot equal -3. And I got everything. It's kind of in a list. We're good to go. All right. So go ahead. I'm going to go ahead and pause this. I want you to take about 5-7 minutes. Try number 3 and try number 4. See what you get. And then I'm going to run through those. So I'll come back in about 5 or 7 minutes. So let's take a look at these last two. So here, nothing cancels. So we're good to go ahead and start. There's no zeros or no anything. So we are good to start here. So I don't have any holes, no holes. I do have a vertical asymptote at x is equal to 5. I do have a 0 at x is equal to -1. I do have a horizontal asymptote. They're the same. So at y equals 1. Anybody have any questions how I got the y is equal to 1? They're the same degree. So it's 1 over 1 is your leading coefficient. I like to find my y-intercept. Still, I like to plug in 0. So 0 plus 1 is 1. So it's -1/5 or 1 over -5. That's just going to help me out. So that point's on the graph. Your 0, once again, is -1, 0. So that kind of gives me a starting spot. You can go ahead and write the domain if you want to. So I have a vertical asymptote here at x is equal to 5. I have a horizontal asymptote here at y is equal to 0. So I know I can go x and y. So I can do 4 and 6. So 4 plus 1 over 4 minus 5 equals 5 over -1. And then 6 plus 1, oh, I muted myself. 6 plus 1 over 6 minus 5. So I got 7 over 1. So this point would be 4, -5, right? 6, 7. So 4. Is that right? Double check him. Yeah. So I can go ahead and plot those. So 4, -5 is way down here. 6, 7 is way up here. We're good to go. I know that -1, 0 is on the graph, right? I know that 0, -1/5, so that's right there. It should make a little sense. I don't have any holes, so I don't have to worry about that. So now we just play connect the dots. And we're in the right quadrant, so we got the right shape, so we're good to go. It's not going to be super exact. My domain is going to be x No, all real numbers except for x cannot equal 5. All right. Once again, if you got questions on any of them, let me know. Let's move to the last one. The last one's bad. It's a little bit off the graph, but it's okay. So x plus 3, x minus 3, x plus 7, x minus 3. You've seen all these before. We did all these earlier. So those cancel, so I have a 0. I have a hole at x is equal to 3. So I got a vertical asymptote at x is equal to -7. Horizontal asymptote at y is equal to 1. And I have a 0 at -3, right? All that should be done. I also have a y-intercept at 0.3. I just like doing that because it's very easy to do, because you just take the x's away because you're plugging in 0 for x. It's not going to give you good numbers 99% of the time, but it's okay. So my vertical asymptote here is at -7. This is why I don't like this one, because this one and 1. So if I get my chart here, -7. So I'm going to pick -8 and -6. Hey, Bree. So I got -8 over 3 is -5 over -8 plus 7, so -1. So I got 5. So -8, 5. And then the same thing. So -6 plus 3 is -3 over 1, so -3. So -8, 5. 1, 2, 3, 4, 5. It's over here. It's all right. And then -6, -3. 1, 2, 3. Yeah. Sorry, I forgot my negative sign. All right. I also have a 0 at -3. And y-intercept's 3.7, so about there. So I got enough information to get a sketch. And we're good to go. So that's where we're at. Make sure you know how to find your holes, your zeros, your horizontal asymptote, your vertical asymptote, y-intercept. It's a lot of information. If you have your checklist, you got this checklist that you can adapt to it. I'll leave this up at the end if somebody wants, if you need to copy it or anything. Don't worry about the slant asymptotes or the limits. You can change limits to domain instead. But that's kind of a checklist to walk you through how to get a graph every single time. Cool? So on the practice, it's overload. The front side has a ton of problems in finding domain and range. Do a few till you're comfortable. If you want to do them all, feel free. There's plenty of practice. Then on the back side, it's got, Emma, how many graphs are on the back? 6. 9. So good practice. Make sure you know how to do it. Tomorrow, we're going to add in some with multiple vertical asymptotes, so a little bit more challenging. So make sure you got that. And then next week, we'll clean everything up and quiz. So if you got questions, let me know. Other than that, hope you have a wonderful day and get some practice in, and I'll talk to you soon.